Hey guys, Mr. Betts here. Let's take a look at a slightly more complicated example of using a linear approximation to approximate the value of something. In this case, it falls in as a level 2 example because we're not explicitly told, one, what the function is, and two, what the point of tangency is. So sometimes the problems are going to be really straightforward and we're told the function is this and use the point tangent to the curve at this point. We don't have that here. But what we do want to keep in mind is we know the square root of a number close to 50. Specifically, we know the square root of 49, and that's 7. So first of all, we know the square root of 50 is going to be just a little bit bigger than 7 then. But we can also be a little bit more specific and write the equation of the tangent to the square root function to help us approximate this. So essentially, graphically, what we would be doing here is taking the square root function and we plug in 50 and we want to know what the value is. So what our linear approximation allows us to do is say, let's move over a little bit to 49. Let's take that as a point of tangency, a point of reference that we know, write the equation of the tangent line close to it, and take the point on that line at 50, and that's going to be really close to the point on the curve at 50. So we're using a straight line to approximate a curve. So that being said, our function is going to be the square root function. And what we're really trying to do then is figure out an approximation for f of 50. So we're also going to have to figure out what point of tangency to use. This one's pretty easy because we do know what f of 49 is. So f of 49 is 7. So we're going to use the point at 49 comma 7 as our point of tangency. So that being said, we're going to find the slope at that point, which is going to require the derivative. And the derivative at 49 is going to be 1 over 2 times the square root of 49, which is 1 over 14. So the equation of the tangent line then is going to be y minus 7 equals 1/14 times x minus 49. Or we could write that as 7 plus 1/14 times x minus 49. So then to approximate the value of f of 50, we're going to plug the 50 in for x. I do like to keep it in this form because generally we're plugging in a number close to 49. And so by leaving it as x minus 49, that subtraction is pretty easy. So y is equal to 7 plus 1/14 times 50 minus 49. Which is just 7 and 1/14. So that answers our question here. F of 50 is approximately 7 and 1/14. I do want to just check to make sure that our answer makes sense here. So first of all, let's think about whether that should be an over approximation or under approximation. I drew the square root function earlier, and if you can picture that in your head, the square root function is concave down. Which means that the tangent line at any point is going to be above the square root function. And so this right here is going to be an over approximation. If you don't know, 1/14 is half of 1/7. 1/7 is 1, 4, 2, 8, 5, 7 repeating. So 1/14 is going to be about, so this is about 7.071428 and so on. So that's the approximation we get using the 7 and 1/14. And looking at a calculator, the calculator is going to give us, give me just a moment here, I need to plug it into my calculator, the square root of 50 is, from the calculator, I'm going to put equals here, and then I'm going to use an ellipses to show that that does continue. 7.07106 7, 8, and so on. And you can see here the first digit that's actually different is the 4 here versus the 0 here. So our approximation was only off by 4/10,000ths. So the square root of 50 is really, really, really close to 7 and 1/14.